right, a couple of things to make sure you have memorized for metabolism. One will be the definitions of oxidation and reduction. Remember your oxidation and reduction. And for me, I will say every time I'm asked a question about oxidation and reduction, I always fall back on the mnemonic. My personal favorite mnemonic is Leo's over. And that stands for loss of electrons equals oxidation and gain of electrons equals reduction. Some of you in chemistry may have learned it as oil rig, which is fine. I just don't like that one as well, but it works. Oxidation is loss, and reduction is gain. Now, I will say I recommend just memorizing that as a mnemonic because to try to reconcile the fact that something is gaining and reducing in the same definition can be hard for your brain to truly understand. The reasoning is that as a molecule gains more electrons, it will become more negatively charged. So more negatively charged means it is becoming reduced in charge. But again, I'll let that be your choice if you want to fully conceptualize that. For our purposes, just knowing this definition will be enough. All right, next question I have for you is, well then, where are the electrons? So, where are the electrons? Because those are not always pointed out clearly. So for example, for our class, really in many cases, you will be looking for the electrons in the hydrogen. It's going to be our hydrogen atom. And we'll see that a hydrogen atom is actually just a hydrogen ion, which we also call a proton, plus an electron. So a hydrogen atom is equal to a proton and an electron. Remember, your proton is equal to that hydrogen ion. And just remember that you have seen that terminology before, the hydrogen ion. Sometimes we look at the concentration of hydrogen ions to indicate whether a solution is acidic or not. So a high concentration of those hydrogen ions or protons equals an acidic or low pH. But that should be something that's already in your memory bank. All right, now I'm going to ask, can you identify the molecule that has been oxidized or reduced? So one thing we did talk about in class was electrons are not going to have running freely around the cell because they do have the capability of forming free radicals. So these electrons usually need to be shuttled or transported on a carrier molecule. And for our class, the carrier of electrons is going to commonly be this molecule NAD. So NAD is going to be our electron carrier, and it can carries 2 electrons and 1 proton. Now I will say how NAD carries the electrons and protons not quite equally, can also be a little confusing. So don't spend too much time on trying to understand how NAD carries the electrons and protons. Try to understand which one is going to be oxidized or reduced. And said you might have two hydrogen atoms, and those two hydrogen atoms, for our purposes, are going to be coming from that original glucose molecule. Those two hydrogens will each be 2 protons and 2 electrons, and you will see them carried on NAD like so. So we will have NAD H plus a proton. So NAD is going to carry 2 electrons, but only 1 proton, which means we will see this as NADH, plus there will be an extra proton that is just floating freely in the cytoplasm of bacteria. Remember, it's fine to have those protons floating freely in the cytoplasm. We have those all the time. They are not like free floating electrons. We do not want free floating electrons. It's fine to have free floating protons though. All right, so now my next question is, which of these is oxidized and which is for our oxidized form of NAD, going back to your mnemonic, loss of electrons equals oxidation, gain of electrons equals reduction. Where are the electrons? So NAD, does it have the electrons yet? No, so it's low in the electrons here, low in electrons. That means this is the oxidized form. Here on the side, you can see how it has gained the electron. So gained the electron, because you do see that H, and that means that this is the reduced form of NAD. So NAD is oxidized. You cannot see the hydrogen, no electrons, no protons. However, those are harvested from glucose. Now these can be carried on that electron carrier, NAD. NAD will carry 2 electrons and 1 proton to form NADH. And like I said, there will be 1 proton that stays in solution, but it is still going to be around this compound.